In this video, we're going to talk about simplifying and multiplying rational expressions. And remember I said when you see the word rational, I want you to think of the word ratio, which really means a fraction. So I want to remind you about how we simplify or reduce fractions and how we multiply fractions. Okay, so let's take this very simple situation of reducing the fraction 12 over 36. Remember when we reduce a fraction, we say, what can we divide each of these by? Well, we can divide each of these by 12, right? Or the highest number we can divide them both by is 12. Now, granted, we can divide them both by 6 or by 3, but the highest number is 12. And I'm going to write this in a different way. Now, what we're used to doing is saying, okay, 12 divided by 12 is 1, 36 divided by 12 is 3, so we reduce that. But I'm going to write it like this. I'm going to show it as this is 12 times 1. That's what gives us 12 in the numerator. And this is 12 times 3. That's what gives us 36 in the denominator. Because I want you to see that when we divide top and bottom by 12, what we're doing is we're canceling the same thing in top and bottom. And that's really how we're getting 1 over 3. So you can think of it as dividing both by the numerator and denominator by 12, or you can think of canceling the numerator and denominator with the same thing. Okay, so let's take a more complex version of that. So if I have 4 over 20, all right, so what can I divide each of those by? Well, I can divide each of those by 4, but I'm going to do the same thing I did before. Is I'm going to write this as 4 times 1, and then I'm going to rewrite 20 as 4 times 5, right? Because 4 times 5 is what gives us 20. All right, so then now we have these x values. Remember, x squared is the same thing as x times x. And then x is, I'm just going to write x. So what can we cross out that's in both numerator and the denominator? Well, we can cross out the 4's, and we can cross out an x in the top and bottom. And then what do we have left over? Well, I have 1 times x in the numerator, so you can write 1x, or you remember 1x is the same as just x. And then I have 5 in the denominator. Okay, so that's reducing fractions with variables in them. All right, so now let's look at multiplying fractions. Now, multiplying fractions, you can do them a few ways. Remember that the basic idea is that we can multiply the numerators together. So if I was doing this one right here, 1 times 2 is in the numerator, so 1 times 2 is just 2. And then 3 times 5 is 15. And that's how we multiply fractions. Now we can always check to see if we can reduce, but I cannot divide 2 and 15 by anything. Now I could do the same thing here, and I could multiply the top two numbers together. 4 times 5 is 20, and then 10 times 8 is 80, and then reduce both of these. That's one way to do that, right? And we could reduce these both by 20, and that would give us 1 over 4. Sometimes, though, I want to remind you that we can reduce before multiplying. So here's how that works. Even though I may not be able to reduce 5 over 8, and I can reduce 4 over 10, we can reduce diagonally as well. So what I'm going to do is I'm going to rewrite these numbers as broken up into their factors. So 4 is the same as, I think of two numbers that multiply to give me 4. That would be either 2 times 2 or 4 times 1, right? So again, I want to think about which factors are going to help me cancel things out. All right, so here in the denominator, do you see how I have 8? Well, I know that 8 can be broken down into 8 times, or 4 times 2. So I'm going to rewrite 4 as 4 times 1. And down here, I'm going to write my 8 as 4 times 2. And the reason I'm doing that is because I know that I'm going to have 4's in the numerator and the denominator. Okay? Now the same thing with 5. 5, the only thing I can do with 5 is 5 times 1. Okay, so I don't really have much option there. 10, I could do 10 times 1, or I could do 5 times 2. So which factors would be more beneficial? Well, I think the 5 times 2 would be better because I already have a 5 in the numerator. So what we see is I can cancel out the 5's. They're both in the numerator and denominator. And I can cancel out the 4's that are both in the numerator and the denominator. And then I can go back and do my multiplication across, just like what we did here. So I can do 1 times 1 is 1, and then 2 times 2 is 4. And the reason I'm showing you this, yes, we get the same answer, and really this top one is easier in this example. But the reason I'm showing you this is sometimes it will be easier to reduce first, because sometimes these numbers will just get too large, and sometimes they might have variables in them. So let's look at some of those examples. All right, so if I wanted to simplify this one, notice that this is just simplifying. There's no multiplying involved, but really simplifying and multiplying, the process is the same. So let's kind of nail down that process. We really want to break down, the first thing we want to do is say, hey, can we factor? Can we divide things, or can we break them up so that we have things to cancel? And then once we have factored those things in the numerator and denominator, then we want to be able to cancel things that are in the same in the top and bottom, in the numerator and the denominator. Okay, so that's the whole idea. So let's look at this example 1. We want to look at the numbers and we want to look at the variables. Let's look at the numbers first. Can we break up 8 and 24? What can we divide both of those by? Well, do you notice that 8 can go into 24? So I'm going to leave 8 as 8 times 1. And then 24 I'm going to break into its factors of 8 times 3. Okay? So that's so I know that I can cancel the 8's in both the numerator and denominator. Now the x, there's nothing that I can do with the x. That's just plain old x. But x cubed is the same thing as x times x times x, or if you wanted to write, that's the same thing as x times x squared. Again, the whole idea is we want to be able to cancel an x in the numerator and the denominator. So what can we cancel? So we factored it out, so what can we cancel? I can cancel the 8's and I can cancel the x's. So notice I'm using the same color to show what I'm canceling. And then that's the only thing I see that's in both top and bottom. So I'm going to write my final answer as 1 in the numerator. And then down here in the numerator, I have 3 times x, or another way of writing that is 3x squared. Okay, so let's look at another example. Here we need to simplify, so we're trying to factor. Now, what I want you to notice here, this is different than any of the ones that we've done before. This is x minus 4. So it's not something that's joined together by multiplication, it's joined together by subtraction, or if we had addition, it would be the same idea. If we have addition or subtraction, you have to use your factor techniques that we did back in the quadratic unit. Okay, so if you have addition or subtraction, then use your factor techniques. And remember, we had that flow chart. And if you want to get that flow chart out right now, pause the video and get that out so you can remind yourself of our factor techniques. And I'll even put that here. Okay. And make sure to bring that to class so you can see how to use that in class as well. So x minus 4, so our flow chart would ask us, do we have a GCF, is it greatest common factor? Can I divide each of these by something? No, I can't. My GCF is just 1. And then, so then I have, how many terms do I have? Well, I have 2. Is this a difference of 2 squares? No, it isn't. Is it a sum or a difference of 2 cubes? No, it isn't. And that means it's factored. So we can't do anything with that numerator. The denominator doesn't have anything multiplied or added or subtracted, so that's as far as we can get with that. So here's the catch-22 of this. We can't factor, So here we can't factor anything. And I can't cancel anything. And here's the thing that most people want to do. Most people see these x's and they want to do this. They want to cancel those. Well, we can't do that because canceling in top and bottom means that I have to cancel things that are multiplied. Okay, all the canceling that we've done so far, and I'll scroll back up so you can see, all of these things that we are canceling, they were all multiplied in between, right? So I can only cancel things that are multiplied. This right here, this x is joined with the 4 by subtraction. So I can't break that up. I always call it as, think of these are married together, okay? Married together with addition or subtraction, and you don't want to break that up. Don't be a homewrecker. Okay, so we cannot cancel those. So this is already simplified. So if this ever came up, you would say it's simplified. That's as far as we can go. All right, let's look at an example maybe where we can simplify. So looking at this one, so notice that we have addition here, right? So as soon as you see minus or plus, that means I got to think about those factoring techniques from the flow chart. All right, so look in the numerator. Do we have a greatest common factor? No, we do not. How many terms do we have? We have 2. Are they a sum and difference? Sum or difference of 2 cubes, or is it a difference of 2 squares? No. So the numerator is factored already. So I'm going to go ahead and write that as the same thing, x plus 2. We can't factor that. Now let's do the same thing for the denominator. Do we have a greatest common factor? Here, yes, we do. We can divide each of these by 3, right? Do you remember doing this? If I can divide each of these by 3, and remember what we do, we put 3 in the front, parentheses, and then what do we get after we've divided by 3? Well, here I'm just going to get 1x, and then here I'm going to get a plus 2. So that's the greatest common factor, the GCF. Then with what's left over, is this a difference of 2 squares? No, it's not subtraction. Is it a sum of 2 cubes? No, this would have to be x cubed. So that's as far as we can factor it, but we did get to factor it a little, didn't we? Okay, so we write that. Now that we've factored it, now we ask, can we cancel anything? Well, is there anything that's multiplied? Yeah, this is 3 times this parenthesis. All right, so if I had 3's that are multiplied in both numerator and denominator, I could cancel those. Or if I had x plus 2's in top and bottom, I could cancel those. Well, look at this. I do have an x plus 2. Well, what is this x plus 2 multiplied by? I said they had to be multiplied by something, didn't I? Well, we never write this, do we? But we always know that this is multiplied by 1. Okay, so if that helps you to write that, go ahead and write that. But that whole thing is multiplied by 1. So we can cancel the x plus 2's, and what does that leave us with? That leaves us with 1 in the numerator and 3 in the denominator. So what's kind of nice about this example is this really complex looking rational expression reduces down to just this simple fraction of 1/3. That's our final answer. Okay, so let's look at some more examples. All right. Yes, this looks more intimidating, doesn't it? But we're following the same idea. Can we factor? So let's look at our factor flowchart. Let's start in the numerator. Is there GCF in all of these 3 terms? No. Okay, well, how many terms are there? There's 3. Okay, we don't worry about the special factor pattern, but we're going to do that diamond factor. Remember, we're looking for 2 numbers that multiply to give us 10 and add to give us 7. So remember, in each of these expressions, they start with x, and then these numbers have to multiply to give us the 10. Remember, the 2 numbers multiply to give us the c value, add to give us the b value. So that's going to be 5 times 2 gives us 10, and 5 plus 2 gives us 7. So that's how we factor the numerator. And the denominator. Okay, so do we have a GCF? No. We have 2 terms. Is this a difference of 2 squares? Yes, it is. We can do the square root of x squared. Remember, that's x. And we can do the square root of 4. Remember, we don't do square root of -4. We just do square root of 4. This establishes the difference of 2 square pattern. The square root of 4 is 2. And again, I'm going to remind you that with that factor pattern, we have x plus 2 and we have x minus 2. That's the difference of two squares pattern. Look at your flow chart to help you remember that. All right, so now that we have factored that, then we look for anything that we can factor out or cancel out. So do we have anything that's multiplied? Yes. These two things are multiplied, aren't they? And these two things are multiplied. That's what those parentheses mean. Is there anything that's the same? The whole parentheses that's the same? Yeah. The x plus 2's are exactly the same, aren't they? So I'm going to be able to cancel those out. So what is that going to look like? That's going to look like x plus 5 in the numerator and x minus 2 in the denominator. Okay. And can I do anything else with that? No. So this is my simplified form right here. Okay. So that may not look like much, but it's a lot more simple looking than what we started with. All right, so you can see that factoring is very important in these examples. All right, so let's look at this one. We have to factor the numerator and denominator. So let's start. Notice that there's no GCF and we have 3 terms. So we're looking for, remember this is x times x, that's what gives us the x squared, and we're looking for 2 numbers that multiply to give us negative 15 and add to give us negative 2. So that's going to be negative 5 and positive 3. And again, if you need to pause the video or go back and review how to get those numbers, then that's fine. Okay, so that's the numerator. Let's do the same thing on the denominator. Denominator is kind of the same boat. We don't have any greatest common factors. We have 3 terms. So we want to find 2 numbers that multiply to give us 3, add to give us 4. Well, there's only 2 numbers that multiply to give us 3, and that's 3 and 1. Okay, so now, do we have anything multiplied? Yes, we do. Do we have anything that's the same in the numerator and the denominator? Yes, the x plus 3's. So what's left is x minus 5 and x plus 1. Remember, we do not cancel those x's, right? Those are joined together by pluses and minuses. They're not multiplied. You can only cancel things that are multiplied. And that would be our final answer there. That's simplified. Okay, so now let's look at some multiplication problems. Multiplication, like I said, is very similar to simplification. It's just there's more things to look at, more things to simplify. All right, so notice that we don't see any pluses or minuses. These are all multiplication. So that's good. We don't have to worry about doing our flow chart. We just have to break down our numbers, don't we? So what I'm seeing here is I'm noticing if I look at all the numbers in my numerator, so I'm looking at 6 and 9, and I'm looking at 3 and 12. Okay, but I'm noticing the 6 and the 12. Do you see how 6 goes into 12? So I'm going to keep the 6 times 1 in the numerator. And then in the denominator, instead of doing 12, I'm going to do 6 times 2. And again, that's what my eye is drawn to because I've noticed that 6 goes into 12. Okay. Now, if I'm looking at the other numbers, the 3 and the 9, I also notice that 3 will go into 9. So I'm going to keep 3 as 3 times 1, and then I'm going to change 9 to be 3 times 3. Okay, and again, that's just so I can tell what I'm able to cancel out. Alrighty. So that's the numbers part. Here, I'm going to do the y's. I have y squared. That's going to be y times y. Down here, I'm going to have a y. Here, I'm going to have 3 y's. 1, 2, 3. And then down here, I have 6 of them. So you can see how it may not be a good idea to write all these out with variables. 1, 2, 3, 4, 5, 6, because it might be overwhelming to have to keep track of how many of those we can cancel. So we'll do that this way, and then I'll show you another way you can think about canceling. So what can we cancel? The 6s I can cancel. The 3s I can cancel. Doesn't matter which 3 you cancel. And if you want to think about the 1s cancel as well. So I really just have 3 in the numerator and 2 in the denominator. All right, so now all of these y's, now I could start canceling. Like I could say, okay, these 2 y's cancel, and then this 2 y's cancel, these 2, and then these 2. And then what do I have left? I have 1 y left in the numerator, and then I have 3 y's left in the denominator. Okay, but then I still have y's that I can cancel, so I need to do it again. So, so what I might suggest to you, instead of drawing out all of those y's and keeping track of them, is here's what I suggest you do. How many y's do we have total in the numerator? We have 1, 2, 3, 4, 5. We have y to the 5th. And then down here, how many total do we have? We have 1 here, and then we have 6 here. So that's a total of 7. And remember how we talked about exponents and how all we have to do is either add or subtract the difference between them when they're in the numerator and denominator. So I have 2 more y's down in the denominator than in the numerator. So all 5 of my y's in the numerator will cancel, and then 5 of them will cancel down here, and I'll be left with 2. So I'm going to have 3 over 2, and then I'm going to have y squared left in the denominator. So if you're comfortable with those exponents, then I would suggest doing that. It's a lot more simple and a lot less to write. However, if that's still confusing for you, maybe it will be more helpful to write out all those y's. Okay, so that's an example without any addition or subtraction, right? So in this example 7, I do have some addition and subtraction, so we got to go back to our factoring flow chart. So where do I see some addition and subtraction? Well, in the numerator here, I see a subtraction, so I need to go through my list. Is there GCF? No. I have 2 terms. Is it a difference of 2 squares? Yes. I have the square root of x squared. That's going to give me x. And I have the square root of 25. That's going to give me 5. So let me go back and rewrite this other numerator. Notice I didn't do anything with this first numerator because it doesn't have addition or subtraction. But this one here, it had addition or subtraction. That's why we're doing the difference of 2 squares pattern. Oh, no, this is 5. X plus 5, x minus 5. That's how we factored that numerator. All right, let's look at this denominator. Can we do, this has a plus, so I'm doing my flow chart. So can we do a GCF? Yes, we can. We can divide those by 3. So that's going to be 3 in front of the parenthesis, and then what's left over? X plus 5. Okay, and then this denominator here is just x. All right, so do we have anything that's multiplied? Yes, we do. We have 4 times x times this x plus 5 times the x minus 5. In the denominator, I have 3 times x plus 5, and then this is times the x. So anything that's times, we can cancel in the numerator and denominator. So if you notice these x's, those are multiplied, so I can cancel those 2. I also have parentheses x plus 5 that I have both in the numerator and denominator. The 4 and the 3 I can't cancel. On the x minus 5 I cannot cancel, so those are going to be left over in my answer. So I'm going to have 4 parentheses x minus 5 over 3. And that's as far as I can go. So we multiplied everything, we simplified it all out, and we did it by factoring and by canceling. This last one, actually I think this last one I'd like to do with you in class. So we'll keep this one blank, and we'll make sure we do that together in class because there's a little bitty trick to it, And I'll let you can try it and see if you can figure it out, but I want to talk about in person.